Let's start talking about this stuff. Homework 3 is out, as promised. My deadline for myself for releasing homeworks is always the Monday that the content for that homework starts. This homework now, in 4 weeks on that Monday, before that day, you can expect homework 4 to be released. I want to release homework 4 over spring break. Hopefully I get that out there. Not that anybody will be ready for it, but I do want to get that out of the way so I don't have to think about it any longer than I have to. But homework 3 is out. We're going to do, I won't go through the whole thing today, but just a quick overview, and I'll keep jumping back to this as we learn more about the content required for this. So for this, I have some HTML for you to drop in your page. You can just cut and paste the HTML, that's fine. In lecture I don't know exactly which lecture, but we have a little bit of flexibility in these next 3 weeks. I'll go over all this front-end code and explain what's happening with that. There's also a lot of JavaScript, enough that I didn't even paste it in the document itself. You'll have to go to the link and get a good amount of JavaScript. Not too overwhelming, but I pasted in the document, and it was like a page and a half, and it was just clutter. So add that to your page. That's going to be all of the code to set up both a WebSocket connection and a WebRTC connection, and do all of the front-end stuff for you. Again, this isn't a front-end course. Maybe someday I'll force students to do the front-end stuff as well, but at least this semester still. I'll give you all the front-end stuff, and your task is to build the server that's going to make it all work. And don't forget to leave that welcome. If you deleted that at some point, look at what that function does. I mean, if you're modifying my sample pages, I'm sure you know what to do here. But if you did delete that, if you changed it, take a look at the welcome function. There's important stuff in there for the setup. And then let me just go through the objectives this way. Objective 1, WebSocket Handshake. That's what we're talking about today. You'll learn everything you need to know about the WebSocket Handshake today. I'll have examples on Friday and week 3 of this content to make it much more concrete. But at the very least, you'll have all of the knowledge that you need to be able to handle this WebSocket Handshake after today's lecture. So after today, Objective 1 is on the table. After Wednesday, Objective 2 is on the table. We'll talk about everything you need for Objective 2. This is going to be, Objective 1 is establishing a WebSocket connection. Objective 2 is using it for live chat. So users can interact with each other, send messages to the group chat. Objective 3, adding more features to the WebSockets. So instead of just having a connection and live chat, we're going to add just a few more features to it. Handle disconnections gracefully. Handle large messages. For Objective 2, you only have to handle messages up to 125 bytes, very small messages. Objective 3, we're going to handle arbitrary size messages over 65K. So we could handle messages up to megabytes, for example. And once you can handle megabytes, you can handle gigabytes. It's the same thing. Objective 4, just like Objective 4 in Homework 2, make it persistent. Start adding things to your database. Again, this one, kind of free if you have everything else set up fairly well. Just like in Homework 2, Objective 4 kind of seems free if you have everything set up, and especially if you've been using a database all along. So Objective 4, don't overthink it. Get all of your chat history in a database, and also add a path to get the chat history. So when the page first loads, the browser is going to make a request for all of the chat history. Get a big JSON array of all of the chat history, all the history of the chat. I don't have another way I need to word that. And then the page will render, the JavaScript will render that to the HTML, and the users will be able to see all of that content. And then at that point, they have a WebSocket connection established, so any new messages they're going to receive over the WebSocket connection. So instead of loading up the page and seeing nothing, which will happen before Objective 4, after Objective 4, you'll load up the page, see all of the chat, and then be able to get the new chats in real time. So we do actually get a new feature, not just persistence. We actually get users able to get the entire history. In Objective 5, I'm excited about this one. Establishing a WebRTC connection, which, as it turns out, isn't all that hard. I've been, since the beginning of the semester, I've been going through all kinds of tutorials and making sure this is feasible for an assignment. It actually turned out to be kind of easy, because most of it's done on the front end. But nevertheless, WebRTC is going to establish a video chat peer-to-peer connection. So users can video chat basically like I guess like a Skype call. Not that anybody uses Skype anymore. And maybe someday we'll eventually make this like a Zoom call. Not this semester. You can assume there's exactly 2 users for this semester. So it's a video chat call. And then maybe, I don't know, maybe next semester I'll have students do a full like Zoom, a Zoom feature. But if you can do 2, you can do 20. It's not new concepts once you scale it up. Once you know how to do 2, you'll know how to do 20. And they have to force you to do 2 peers. And we'll talk about WebRTC next week, in 2 weeks, I should say. And that's it. So that's what's coming up. So we got live chat with history and then video chat. And sometime in the future, WebRTC might be multiple objectives and multiple features and stuff. Since it's brand new content, I want to confine it to one objective. So in the worst case scenario where things go terribly wrong with WebRTC stuff and there's all kinds of issues, maybe it doesn't play nice with specific Docker configurations and stuff like that, I want to confine it to one objective so it doesn't do too much damage. It's very limited in the damage it can do. But at this moment, I don't foresee any issues with it. I think it's going to go pretty smooth, but I've said that before and had disasters, so we'll see how that goes. Are we allowed to ping at Jesse during lecture? Sure. I mean, I can't stop you. Basically everything in here is pinging me. But if there's something that really needs my attention, because I don't always read every message in the chat, if there's something that really does need my attention, then yeah. Yeah, but as Toadfish says, preferably, I don't think we have any TAs watching the chat in this lecture. Ruslana was, but I don't believe she's been watching the chat lately. She hasn't been in the lecture hall. So it's really up to students to ping me if something needs my attention. We're allowed to ping Jesse at 4 a.m. I don't know. Fine. Most of I was up at like 3 a.m. yesterday finalizing the 116 homework, and 4 a.m. the day before finalizing this homework. So what's that? If I'm not awake, I won't get the ping anyway. I don't have notifications on. I'm not crazy. For objective 3, is there a cap on the file size we need to be able to upload? It only says large files. 17 petabytes is reasonable. I assume you're talking about homework 2. I assume I'm the only one talking about homework 3 at this point. The only one thinking about homework 3. It's usually how it works. Large images, there's no hard cap to it. But if you can handle like 1 to 2 megabytes, you're going to be fine as long as you're not cheesing it. So if you're handling 2 meg, I don't want to say a hard cap, because if I say 2 megabytes and then somebody sets their, when they're reading from the TCP socket, they set that buffer to 2.5 megabytes and call it a day and don't do any buffering, you're still not getting full credit for that, even though you handle up to 2 megabytes. So it's not a hard limit. The limit is you have to actually buffer. If you're actually buffering and you handle 2 megabytes, then yeah, you're good. But if you're handling 2 megabytes and you're cheesing it by doing something that's shortcutting your educational experience, then no, you're not getting full credit for that. You have to buffer. You have to understand what buffering is, especially in homework 3. Like, buffering comes back. You're going to have to buffer right here as well. I mean, I guess you could try the same shortcut, but we're going to look for it again. You have to actually buffer. That's my short answer to that. If you're buffering, your code handles gigabytes. If you're not buffering, your code doesn't handle much of anything. So anywhere in that range that makes sure that you're buffering is what we're looking for. I skipped your question. Well, you were in the middle of the off-topic stuff. Oh, yeah. Oh, you did have an actual question. Homework 2, objective 4 is having persistent meant to load in all the data from Mongo to HTML each time, or editing HTML and save the change. To me, they look the same for now. If you're saving the HTML in the database, I mean, I guess I'm not mad at that. But the persistence has to be in the database. So RAM is going to be blown away. And we're also going to look at your app code. If you're saving the HTML to a file on your app, in your app container, and shortcutting the database, then that's not full credit either. You have to have some sort of persistence that's stored in the database. So if you do render, so if you theoretically you get a message with the form and an image, you render your new HTML, you save the file to disk, render your new HTML, and have an updated HTML, and then just serve that statically without doing templates each time, and that HTML is stored in your database, I'd be okay with that. If that HTML is just saved to disk, then I'm not okay with that. You have to use the database, no shortcutting the database. It's going to be my answer to most of these questions. I assume, maybe I'm wrong, but I assume most of these questions are like, I thought of an easier way to do this, can I do it? But you got to actually learn what you're supposed to learn in this course. As long as you're learning what you're supposed to learn, I'm happy. If you're not learning what you're supposed to learn, then I'm not happy. And your grade will reflect that. When the TAs and I talk about grading decisions like that, when we have these edge cases of strange things that some people do, that's what it comes down to. We say, are they still learning what they're supposed to be learning? And that's it. That's my question. That's the only thing I really care about. I don't care if you did it my way or the way I showed it in lecture. Are you learning what you're supposed to be learning? Did you understand the concept and find a suitable solution for that problem? If you did, then I'm happy to give you full credit. But if you cheated the system, then no. So it depends on exactly how that's set up, Toadfish. Homework, and same thing. Homework 2, I successfully work with Chrome, but Safari and Firefox not so much. It depends why. So Chrome is very forgiving. Chrome is very advanced and will find your errors and fix them usually. So if it doesn't work in Safari and Firefox because you did something wrong, and then Chrome just happens to fix your mistake, well, then you're not getting full credit for that. But if it's something where there's actually a bug in Safari and Firefox, which does happen, I talk about the redirect thing in Firefox all the time. If it's actually something wrong with those browsers, which is not, it should not be your first thought when that happens, it's probably something wrong with your code. But if it is actually something wrong with the browsers, then fine. Is there a limit for buffer in JS? Not that I know of. Like a limit for the size? I don't believe so. Like the buffer, you mean the buffer function call, like buffer.from? But if you're talking about the TCP buffer, I think it caps out at 64K. If you have a huge image and no buffer setup, will image not show up? The image won't show up and your server will probably crash. In almost every instance, your server is going to crash too. You'll upload a large image and just everything breaks. There's a size limit to each HTTP. I'm happy you have so many questions. I'm happy to answer these. I guess there's a size limit to each HTTP packet that contains, so the image might be broken. The image will be broken up, but TCP handles it at that level. So by the time you're reading from the TCP socket, it was already broken into several HTTP packets, reassembled, and then ready for you to read off the TCP socket. TCP abstracts all that out for you, so you don't have to think about IP. Did I say HTTP? Did that question say HTTP? Each HTTP packet. I assume you mean IP, but the IP packet stuff is already taken care of. It's all one HTTP request, but it's multiple IP packets, but TCP takes care of the IP stuff for us. Yeah, I wouldn't even call that a loophole, Toadfish. As long as you're saving the HTML to MongoDB. What? Update HTML, save. Oh, without using, I thought you said with. Yeah, without using MongoDB, yeah, you gotta use MongoDB. No loophole there. It's something we'll look for during grading. It is, isn't it? Did I forget to put it in there? Look through the code and verify that you're using the database. It's right there. It's in the testing procedure. It's fair game. So right here, bullet point 5, the TA is going to do that and knock you at least down to a 2, if not a 1. I mean, again, well, if that becomes a discussion with the TAs during grading, which it sounds like it might, we'll decide if you learned what you're supposed to learn. This is Chrome, WebKit boundary, and this is Firefox. Yeah, there's no, like that WebKit form boundary, like whatever that string is for the boundary, that's completely up to the browser, and you should be able to handle any boundary. If your code is searching for the string WebKit form boundary and then not finding it when it's Firefox, like that's a problem with your code. You didn't satisfy the protocol at that point. All right, well, it's starting to come up in chat, so let's talk about this one. The TAs and I were talking about the deadlines, and homework 2 was due this Friday. It's no longer due this Friday, it's due next Friday. So you have a 1-week extension on homework 2. We were talking about every time. I swear, every time I give an extension, like, it's, I should always give extensions. I get a round of applause all the time. So, so the discussion with the TAs. So the discussion with the TAs was, are we going to grade over break? And the answer was overwhelmingly, we don't feel like it. So if we're not going to grade over break, why make it due before break? So we'll give that time to you. And then we'll grade the week that we come back from break. Otherwise, nobody has any chance to do anything over break if you want to. Now, I usually have, in the reason I had the deadline, I have to give this disclaimer every time. The reason I had the deadline before spring break is, originally is, and the reason I have deadlines on Fridays is because I don't want to kind of take away your breaks and weekends. If you do want to enjoy your weekend and you're stressing over this homework, like it's not going to be a very fun weekend if you're working on 312 stuff, or it'll be a really fun weekend if you like this stuff. So if you do want to enjoy your spring break and not even think about this homework, just pretend that deadline's still Friday, submit it, get it done, and enjoy your break. There's no expectation that you do work over break, but I am giving that option, so do with that as you will, and try not to ruin your spring break. Try to actually get some rest still, at least somewhere in this week. We all get exhausted at this point of the semester, so make sure you're still getting your break. All right, 20 minutes in, let's do some slides. I only have 13 slides, so there's time to do this stuff today and answer questions. How about the old Internet Explorer? If it doesn't work on Internet Explorer, I'm fine with that. It should work on Edge, though. The latest version of each browser it should work on. Well, any currently active browser. Yeah, and there's no office hours over break, obviously. That's one frustrating thing. Whenever I give an extension, when I give an extension at the end of the semester, and I give an extension so something's due during finals week, and then half the class is like, you're still having office hours, right? Like, no, it's an extension for you, not an extension for me. There will be no office hours over break, and probably no Piazza activity over break. So keep that in mind as well. Support still ends this Friday. All right, let's finally talk about WebSockets. So WebSockets, first let's talk about Ajax. We talked about Ajax just once, just last Friday. But this gave us a way to be able to make requests for more information after the page loads. And then we saw 2 ways, polling and long polling, with long polling being preferred, to be able to have the server be able to kind of send information to the client. Polling was just the server or the client asking every once in a while, like every second, hey, do you have new information for me? Do you have new information, blah, 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 et cetera, et cetera. Long polling was, hey, do you have new information for me? And then the server would just sit there and wait until it had new information and then responded to the HTTP request, or timeout, and then the client sends another request. So the client always has an active HTTP request that the server can respond to whenever it has information, which gets us live updates, that gets us what we're after. But we have a more modern solution. We want to talk about WebSockets. So WebSockets is going to give us full duplex communication, meaning the client and server can just send information to each other at any time over this WebSocket connection. So now we can have what we call server pushes, where when the server has new data, it can just send it over the WebSocket connection. No questions, no thoughts about it, no complex long polling setup or anything. We have a WebSocket connection, and the server just sends information over that WebSocket connection, and it's done. So we have full two-way communication in real time, or at least real time minus network delays, and we can get that live interaction that we're after. In homework 2, we have interactions, but they're not live. You have to refresh the page every time you want to see the new information, the latest images, the latest posts that people have made. Now we want to update that to be fully real time and interact in real time, which is what we expect from any modern website. We don't expect to have to refresh to be able to see the latest messages that people sent. I'm not sitting here on Discord refreshing every 2 seconds to see if you have new messages. I want it to just be live. And I don't think that's too much to ask these days. And we don't want to use long polling because long polling is complex to set up, and I don't know. I just don't feel like having you do long polling in the course. It's tedious, it's painful. Let's go right to WebSockets. So, and this is the crux of it. This is how WebSockets work. A quick overview of WebSockets. Of course, we're going to talk about the details all week, but the quick how WebSockets work. So HTTP, the very first thing in HTTP requests you have to do is create a TCP connection. We create the TCP connection, which is already a full duplex, two-way communication stream. It's a socket. The client can send information over the socket. The server can send information over the socket to the client. And we kind of waste TCP when we use HTTP. We establish the TCP connection, send a HTTP request, get an HTTP response, and then sever the connection. WebSockets say, why don't we just keep that connection open? Like, let's just keep it open, and then we're done. That's all WebSockets are. Let's just keep the TCP connection open until one of us decides to close it, and just keep sending messages back and forth over the TCP connection. Super simple. It's simpler than HTTP in a very real way, and that's it. That's what WebSockets does. So WebSockets is kind of peeling back HTTP and saying, let's just use the TCP socket. What if you use Windows XP? You should get a new operating system. Windows XP was fine back in the day, but not anymore. So we're going to establish the TCP connection, and our server only really speaks HTTP. We have to talk HTTP. We have an HTTP server. So we do still have to start with HTTP. So the client's going to send an HTTP request, which is going to be an upgrade request. So this HTTP request is going to say, hey, this TCP connection that we're communicating over right now for this request response HTTP protocol, let's just leave it open. That's what the HTTP request is going to say. The server says, yeah, let's do that. I'm good with that. And then they keep that connection open and start communicating via WebSocket frames. So whenever we send a WebSocket message, it's going to be a WebSocket frame. You're going to spend more hours than you want parsing these frames and creating these frames and figuring out exactly the format of the frame, which isn't too bad, but it does get us to, which I don't know if I'm the only one, but I get excited about it. It gets us to bit level parsing. So we start with string level parsing, string parsing in this class, string manipulation. We get down to byte manipulation, which we're at with homework 2. Because that image can't be converted to a string, we have to work in the world of bytes until we can extract that image out of there. When we get to WebSockets, we're talking about bits. We're going to do bit level manipulation. The reason I get excited about it is we have like entire courses that talk about bits. We have 191, which I think has changed over the years, but I believe still talks about bit level operations, XOR, and ANDs, and ORs, and all that stuff. We have 220, which gets into the bit level representations of ints and doubles and things like that. We have 341 that talks about all these low level details, but it almost never actually affects you as a programmer. You never often don't ever have to write code that is aware that your integer is a 32 or 64-bit value with one's complement. We still don't have to worry about one's complement in this class, thank goodness. But we never really have to do it. With WebSockets, you actually have to pull out all that bit level understanding and apply it to your homework. So we actually have an application of all that stuff that we make you learn. That computers are only ones and zeros and stuff. Never really matters. Here, it's actually going to matter. And you're going to have to do some bit level manipulation in your code, which is fun. I think it's fun. So is WebSockets an added layer on TCP connection? Yes. So it's another application level protocol in the network stack, just at the same level as HTTP. So HTTP works on top of TCP. WebSockets is another protocol on top of TCP. So WebSockets technically doesn't require TCP, but we'll almost always use TCP for it. It's just where it fits into the internet at large, or the web, I should say. But the protocol could be used outside of TCP sockets, I suppose. But that's how we'll use it, on top of a TCP socket. TCP is nice because it gives us that reliable communication. I send a message to another device on the internet, and I know it's going to get there in its entirety. So TCP is nice for that. So we're going to use TCP for most things, except WebRTC. By the time we get to that, the peer-to-peer connection will actually use UDP. So we'll get a little bit of UDP conversation in this course. So we get the request. Is this slide saying everything that was on the previous slide? But there is a WebSocket handshake that we want to talk about today, which is going to be your objective 1. So let's talk about the details of that handshake. What's this HTTP request look like? And what's the HTTP response going to look like? This request and response that says, let's change this TCP connection to a WebSocket connection. So the most important part are these two headers. So we're going to get the upgrade request from the client, and it's going to contain these 3 headers: connection upgrade, upgrade WebSocket, and the most important one, sec WebSocket key, and then some random value. Purely random. I mean, maybe the browser has some algorithm that it uses with some sense to it. To us, it's going to be purely random value for this key. We're going to respond with a 101 response code. We haven't talked about 100-level response codes yet. 100-level is where we're going to switch away from HTTP. We're going to respond with a 101 switching protocols with the same 2 headers: connection upgrade, upgrade WebSocket. Make sure you have those 2 headers. And then also, the most important one, sec WebSocket accept, which is going to have a determined value, which is determined based off of this random key. And today we want to mostly talk about how to take that key and then generate the response. The rest of the protocol is pretty simple. Connection upgrade, upgrade WebSocket are always going to be the same. That's saying, hey, let's upgrade this to a WebSocket connection. But we need to generate this accept, which is going to take a little bit of work. Otherwise, it's super simple. And then after you send this response, don't close the connection. Just don't close it. So if this is Python, this is one case where you want to enter an infinite loop. You're going to put, at least what I recommend, put a while true, and then read from the TCP socket inside that while true, and make sure you never get to the end of that receive method. You have your method that's going to be called when you, your handle method, sorry, not receive. Your handle method, make sure you never get to the end of that handle method that you have. Once you get to the end, the TCP connection is closed, so you don't want to get to the end of that connection unless the WebSocket connection is closed, which we will talk about Wednesday, probably. If the WebSocket connection is closed, then get to the end of that method, return, exit out of that, and then the connection will be closed. So if you upgrade to a WebSocket connection, you want to enter an infinite loop, while true, read from the TCP socket, handle it as a WebSocket message, and then go back up to the top of the loop and read from the TCP socket again. Don't let the connection close. If it's JavaScript, mark that connection as a WebSocket connection, and then when you get a new message that the data on, or on data, I forget the exact, I think it's on data, when that callback is called, that'll be called for any of the connections, and you'll have to check whenever you get data, is this one of my connections that I marked as a WebSocket connection? If so, then make sure that you parse that as a WebSocket frame and not as an HTTP request. Don't run your HTTP request code when you're getting a message, when you're getting bytes over a WebSocket connection. So how do we go from that key to the accept? Well, this is it. This slide is your best reference for objective 1 on the homework of at least of how to compute that accept, which is the bulk of the difficulty with that. Aside from maybe keeping the TCP connection alive, making sure it's not closed. So we get that key. We're going to read that key header. And I promise this is real. We're going to append this string to the end of it. We're going to read the key as a string and append this exact string to the end of it. Somewhere in your homework, you're going to have this string hard-coded in your code somewhere, and you're going to append it to the end of the key. This is a very specific, globally unique ID made for WebSockets. It's in the WebSocket protocol. If you look at the RFC, this string is going to be in there. If you look at any library that handles WebSocket connections, you'll find this string somewhere in that library. This is just part of WebSockets, is this string. So we're going to concatenate that to the end of the key, and then we're going to compute the SHA-1 hash of that concatenated string. And we're going to convert that using base 64. We're going to base 64 encode it, the hash, and that's our accept. So when we take the SHA-1 hash, we're going to get random bytes, and we have this problem that we've had all semester. Those bytes can't be converted into a string. But we need to set it as the value of a header, which has to be ASCII only. It has to be an ASCII string. So we have a bit of a problem here. We have random bytes, and we need to set it to a string. Base 64 encoding is designed to handle that exact situation. It's going to take any random bytes, and technically you could use this for your images if you tapped into the HTML forms. Like, it'd be a pain, but you could technically do this. Base 64 is going to take any random bytes and encode them into ASCII text. And then we can use it as a header. We set it as a header. All right, so why this seems really arbitrary, and to be honest, it is. It is really arbitrary. There are two big reasons. One, avoid caching, which I think is less interesting. A lot of like load balancers and servers, if you have anything in between, so there's the client, there's your server, anything in between the client and server that you have, you might have a big, large distributed system with all kinds of things in the middle here, and those things might have a lot of aggressive caching that you don't have control over. With this random header, it's going to prevent some of that caching from happening, because we don't want this to be cached. We don't want to get a request and have something go, oh, I know the server last time it got a request that looked identical to this, sent this response. And HTTP is stateless, so it's got to be the same response, right? And then just responds with the accept and says, yeah, this is a WebSocket connection now, but the server never got the request. So it never knew to keep the TCP connection alive and treat it as a WebSocket connection. So to avoid caching, we have this random key, and each request looks a little different, and that aggressive caching hopefully tones it down and says, all right, let me actually make sure this makes it to the server. The more, I think, more interesting one is to make sure that the client and server actually both speak WebSocket. They both understand the protocol. This is an extremely specific thing that you need to do to generate the accept. This will not happen by chance. If the server doesn't actually implement WebSockets, there's like effectively 0% chance that they're going to send back the correct accept if they're not following this procedure. They don't have this exact string. They're not taking the SHA-1 hash and base64 encoding it. It's just not going to happen. So the client sends a WebSocket connection request, and the server doesn't send back the right accept. The client's going to say, okay, this server doesn't speak WebSockets, or the developer didn't understand the protocol. I'm not going to keep this TCP connection open and waste resources on this server that doesn't speak the protocol that I speak. Maybe it's a different version of WebSockets that they're speaking or whatever. This guarantees that both client and server do, in fact, speak the protocol. All right, any questions on this part? Because that's all I have to say about handshakes. We'll do examples and stuff. But that is what the handshake is. Read the key, append the GUI, the GUI'd, SHA-1 hash, base64 encode, return as the accept. All right, so once the connection is established, we have a new format for the messages that are being sent, which is called a WebSocket frame. I'll briefly introduce this today, but Wednesday we're going to talk all about how to parse these frames and how to write these frames. But let's give a quick overview just so we're talking about the whole protocol today. WebSocket frames are going to work at the bit level. We're going to do bit level parsing. And they're going to look like this. So when you send a message over a WebSocket connection, that message has to be in this format, which again, we'll spend at least the whole lecture talking about on Wednesday, probably a lot more than that. This format. These are bits, 1 bit, and then this is like a 4-bit, this is a 7-bit message. So we do have to extract at the bit level. The WebSocket frame is made so that the headers are as minimal as possible, so we don't have much overhead when we're communicating over WebSockets. This is a very nice feature of the protocol. When you establish the connection, you have this TCP connection, there's very little waste here. Most of what you're sending over the connection are the actual bytes of your messages, which we can't say about HTTP. Every time we send an HTTP request, there's this big bulk of headers that are sent every friggin' time. It gets pretty wasteful. WebSocket says, let's be lean, let's just send mostly just the bytes that we need. So it's very minimal, very nice. If you're sending small messages, there's only 2 bytes of overhead in these messages. So when you get a WebSocket frame, the very first bit is going to be a fin bit. I don't think I talk about these right. A fin bit, 3 reserved bits, and then an opcode. So when you read the first byte of that data that you get over a WebSocket frame, you have 3 different pieces of information in that single byte that you can read that you have to parse. You have to parse at least the opcode. The fin bit we're going to assume is only 1. At the top of homework 3, it has some simplifying assumptions. You can assume the fin bit's always 1 and these reserve bits are always 0. And then the opcode is the first thing that you have to read. The mask bit will actually always be 1 as well when you're reading these. And then the payload length, which can either be 7 bits, 2 bytes, or 8 bytes, which is a thing we'll spend a lot of time talking about, exactly how that is. And I misspoke. It's 6 bytes of overhead because we have this mask. And then finally, a masking key, which is 4 bytes of random data. That's very important, but it's 4 bytes of random data. And then your payload, which will be masked using this masking key. So every 4 bytes of the payload data has been XORed by the masking key. Again, more details on Wednesday, but that's a very brief overview of WebSocket frames. So these messages are masked when the client is sending a message to the server. We have the payload that's XORed with the mask and just looks like random garbage, and then you have to read the mask and XOR again to basically undo the XORing and get back to your original message. Again, this is something to prevent caching. Once you, if you're sending messages that look very similar, if they are identical, somebody says the same thing to the chat twice, some aggressive caching system might want to cache that and just return the response, but we need that message to actually make it to the server. So we want to avoid that caching. With 4 bytes of random data, we have a very small chance that that is going to be identical to another message. We have a random mask. The browser is going to generate the random mask, mask all the payload, make sure those things look different, and prevent that caching, no matter how aggressive. When the server sends messages to the client, so when you're sending, your server is sending something to the client and pushing information to the clients, we don't have to mask. There's no masking involved when the server is talking to the client, because there's no fear of caching at that point. No server is going to cache when sending something to the browser. That doesn't make sense. But client to server messages will be masked. In the browser, browsers are really sophisticated these days, by the way. The browsers do so much cool stuff for us. WebSockets too, we just say new WebSocket and give it the path for the WebSocket. This is whatever path, right here, whatever path. I thought I changed that to WebSocket. I think I did in the homework. But the path where you're expecting the WebSocket upgrade request. That's what you're going to see on the server side. You're going to see an upgrade request on this path. So whenever you get a GET request for /socket, if this is on your front end, that's where you need to do the switching protocol stuff, read the key, generate the accept, and then leave that connection open. And we'll be using the WebSocket protocol at that point. No longer HTTP. To send messages, socket.send, and then whatever you want, the browser's going to generate the frame, generate a random mask, mask the payload, generate the payload length, all that good stuff. Browser's going to do all that for us. And whenever we want to respond to message or do something in response to a message, we're going to use this onMessage, give it a function, and then this function is going to get the payload that the server sent, and then we can do whatever we want with that payload. Just print it to the screen. At this point, print it to the console. But that's where we would actually do the stuff. Generate, put the chat messages in the chat, which the front-end code that I give you does all that already. Oh, I got ahead of my slides. I really got ahead of my slides. So let's see this. We do have a little bit of time here. I want to do one example here. And let me mute this first before I do something dumb. Oh, I can't even. Does anybody know a website that uses WebSockets that I don't have to log into? Are you just guessing? Yes. I don't want your best guess. Like I need. Reddit doesn't use WebSockets, I don't believe. I didn't ask for you to guess. What? I don't think I use WebSockets at 1.16 right now. I think I used to, but I removed it. Oh yeah, towers, yeah. Good call. I was gonna go to, so I usually go to Twitch during this, but I don't know, Twitch, when you're not logged in, has some god-awful recommendations these days. They're basically a hot tub site these days. Or did that meta pass? I don't know if that's still a thing, but I don't want to show that during lecture. All right, so when we have a WebSocket connection, we're going to see this WebSocket request. I'm using Socket.io here, so it looks a little different than it will for the homework. And you're going to see the response code of 101. So this connection, this TCP connection was upgraded to a WebSocket connection. We can see the request headers we have this key, and we have the accept that was sent in response. And then we can go here and see all the messages that are sent back and forth. There are a lot of them for this game. Every 10th of a second, I believe I have it set to right now. Every 10th of a second, you're going to get a message that has the new state of the game. This is very wasteful, the way I coded this, by the way. But my point here is go to any site that uses WebSockets. You get your key. You have a key that a browser generated, and you have an accept that you know is a valid accept. This connection was established. We do have a WebSocket connection that works and everything. So you have a key example and a valid accept for that key. Well, when I see that, I'm thinking test case. I got my a test right there where I don't have to fire up my TCP server every single time I want to see if I generated the right accept. You have a test case right here. At the very least, put that in the main method and test your code using that example. Go to any site that uses WebSockets, get a test case, and then code until you have that test case right, where you can just click run, and in a few milliseconds, you know if you did it right or not. Strongly recommended to do it that way. Been recommended this all semester, but any way that you can get your code working in a way where you don't have to fire up the TCP server to be able to test your code is always a good thing. You want to be able to test very easily. I don't have enough time to go through the whole demo today, but luckily we have a whole week of kind of flex time where I can show just example after example after example. But I'll go through, without using code, I'll manually take the key and then generate the accept, but not today.